Good morning, flash flood experts. Thank you very much for coming to this important session. In the previous sessions and training, we covered the W flow. Today we are moving to the Sphinx. And just again to repeat the big picture, we used the W flow to model the water over the rural area. Then after that, the output of the W flow, we use it as an input to Sphinx to model the water in the urban areas. So now we finished in the previous sessions the modeling in the rural areas. Now we are moving to the model in the urban areas. And we managed to know in the previous sessions how to install WFlow, what are the important packages, how to run the WFlow, how to prepare the static maps, how to prepare the dynamic maps, also how to do the sensitivity analysis and how to use the Jupyter notebook to plot the results, and also we use the panoply also to plot this different netcdf file and to visualize it. So we finished now with the WFlow, and today we are working with the Sphinx. And this is, as I said, this is the urban model. And the first thing, of course, is the download of the model itself. So in this step, it is better if you have like Windows 10 or 11, and then we need to download this Sphinx, and this is the link. So we need to download first Sphinx. So it will be downloaded as like a zip file, and after downloading we can extract in C. So if you can see here, this is the C drive. This is where I extracted the model. And as you can see, they are like dynamic libraries. Those are very important, those dynamic libraries. And this is Sphinx also to run the model. This PDF, this is just for your information, and if you need to check some of this information, they are available in this PDF. But even if you delete them, they will not affect the model. But these are the core and important files. You extract them in C under the name Sphinx. So this is our model. We downloaded here from the official website of Deltaris to model the flood over the urban areas. Then after that, as I said, we downloaded the model and we extracted in the C. And today we are going to explain and to give an introduction to the key input files and output files for this Sphinx model. So those are the key files, for example, the input, and those files, we require them to run the model. So if they are not available, the model will not run. The first file, it is DEP subgrid, and the purpose of this subgrid topographic elevation data, and the role it contains high resolution elevation data that allows the model to compute more accurate water depth and flows, especially in areas with complex topography. So this is like a topography file, which is very important. Then after that we have the HydroMT log, and the purpose, this is just a log from HydroMT, and the role here, it contains information about the model setup process. If you use the HydroMT tool to automatically generate your Sphinx model domain and parameters. We also have the precip 2d.nc, and from the name, this is a netcdf file. And the purpose, this is the 2D precipitation input data. And the role here, it provides spatial and temporal rainfall data for rainfall runoff simulation, and it contains also precipitation rate, like in millimeter per hour, or meter per second and distributed over the model domain and also through time. And as I said, this is like an HCDF file. We also have sphinx.crs, and the purpose, this is like a cross-section definitions. It defines like cross-sections for hydraulic structures like bridge, culverts, or weirs. In this assignment, we are not going to use like any weirs or structure here, but this file, if you have like those bridge or culverts or weirs, it is important to have this file. And it is used to compute discharge through these structures using standard hydraulic equations. We also have sphinx.ds, and this is the discharge source locations. And the role here, it specifies points where external discharge enters the model domain. For example, like river inflow, drainage pipe, and also pumping station. It contains also coordinate and discharge time series. Then after that, we also have sphinx.ind, and the purpose of this one, it is an index point file, and the role, it defines the specific grid cells where output time series will be stored, like water levels, velocity, and it is used for creating hydrographs as specific locations. We also have sphinx.msk, and this is like the model domain mask. And the role here, it is a binary file that defines which grid cell are active and also which are inactive. So the active, it is represented by 1, the inactive, it is 0. And it determines also the computational domain and also exclude areas like land that should be shouldn't be included in calculations. Also, we have Sphinx obs, and the purpose, this is like observation points, and it contains coordinate of observation points where model result can be compared with measured data for calibration and validation. So if we have station with some information, it is used for calibration and validation. We also have sphinx.sbg, and the purpose, this is subgrid sampling data, and the role, it is stored also like pre-processed subgrid information that speed up the model initialization, and it contains also like sampled elevation data for the subgrid method. We also have sphinx.src, and the purpose, this is like the general source term, and it defines like the various source sink terms in the model, and it includes also distributed inflows or outflows, infiltration, evaporation, or other mass source and sink. We also have output files. Now we finished with these like input files, but also we have like output files generated by the models. So we went through these input files required for the model setup. And then after that, we have these generated files. So those files, before you run the model, they are not available. But after you run the model, we will have these files. And here we have Sphinx hist.nc. It is an HCDF format. This is the history output time series and the role. The HCDF file contains time series of model variables like water level, velocity, discharge at specific points defined in sphinx.ind on also sphinx obs used for analyzing temporal evolution at discrete locations. Then after that, we have also sphinx map.nc. This is also an output file. This is map output spatial fields, and this is the role. It is netcdf file contain 2D spatial output of maximum or time varying fields like maximum water depth, velocity, arrive time, etc. And it's used for creating flood maps and spatial analysis. So there was this file, it can be used to generate like the flood maps. So the flood maps, we are going to use this Sphinx underscore map to prepare the flood maps. We also have Sphinx underscore inspect model. This is the model inspection output, and the role it is just a diagnostic file created when using Sphinx inspection tools, and it contains also like summary information about the model setup, grid properties, and initial conditions for like quality control. So this is like we went through the input and output, but also we can go quickly through this like file relation and workflow. So this is like we have core inputs here, like sphinx.msk. This is domain definition. We have deep subgrid. This is, we said it is topography. We have precip underscore 2d.nc. This is the rainfall. We also have sphinx.src. This is like the source. We also have sphinx.crc if we have a structural, and this is optional. So some of these files, they are optional, but some of them, they are very important. And as we said, the output after we run the Sphinx, we will have the Sphinx map. This is like the flood map, but also we have the Sphinx hist, and here we will see the hydrographs. And just here, finally, like the key points, there are essential files like sphinx.msk and DP subgrid are typically mandatory for basic simulations, but also we have optionals like as we said, the precip 2D, the Sphinx SRC, and Sphinx DS, Sphinx CRS. These are needed only for some specific scenarios. We also talked about the output. We say Sphinx map and also Sphinx hist. Those are the main result which we will need them after a simulation. There are some diagnostic files like hydro-MP log, Sphinx inspect model. They help with troubleshooting and setup issues. So these are like the different key things that we need to understand. What are the essential files? What are the optional files? What are the output files? What are the diagnostic files? Thank you. Thank you very much for attending this important session, and have a nice weekend. Thank you very much.